Good morning, students. Today we have to discuss about the next group of the Plantae, that is called Gymnosperm. We have discussed in previous classes all non-seeded plant, that is Thallophyta, Bryophyta, and Pteridophyta. Bryophyta, Thallophyta, Bryophyta, Pteridophyta. Among them, only this is Tracheophyta, having xylem and phloem, and these all are Atracheophyta. And we have discussed in these all groups that there are alternation of generation, that is called sporophytes to gametophytes and gametophytes to sporophytes. Today we will discuss this thing also, that from where the sporophytes had started, from where the gametophytes had been started, and what is the end of the gametophyte and what is the end of the sporophytes. But before that particular topic, we will have to discuss about this particular gymnosperm. Gymnosperm is the vascular, tree-like, seeded tracheophyte but are naked seeded. Most of the gymnosperms are perennial. Perennial. It means they produce many times seeds in one lifespan. Vascular means having xylem and phloem. Tree-like, it means they lead their life on land, having well-developed root, shoot, and leaf, having ovule but not ovary. Because we know that the ovarian part will form the part of the fruit. That is epicarp, mesocarp, and endocarp. That is pericarp. Here only ovule is formed, the seed will be formed, but pericarp is not been formed. So it is called naked seeded. And it has well developed xylem and phloem system. Most of the gymnosperms are anemophilous. Anemophilous means pollination takes place with the help of the wind. We will discuss it later on in detail. Now, mainly this gymnosperm is of four groups, four types, that is called conifers, coniferophyta. It is one of the common plant-like gymnosperm. Mostly leads their life in cold area, cold region. Saccharidophyta, it is also very much common, but older plants, and their trees are unbranched, and it leads their life in hot climatic condition. Gingophyta, it is one of the ancient gymnosperm. So it is also called living fossil because the very few examples are survival. and ginkgo biloba is one of the example. In addition of that, genetophyta is also including in this particular branch. Now we will have to discuss some characteristic feature of the conifers, that is the pinus tree and the cypress tree. Now pinus tree, it is branch tree, monoecious, means they are both male and female cones are present in it. It has been observed that their reproductive part, that is the male part and the female part, that is the male gamete and the female gamete, both are compactly arranged to form the cone, where male gamete or female gametes are formed. So it is called cone. And it has been observed that in plant, that male cones are in cluster, like in this cluster. But female cones are large but isolated, not in cluster. We will discuss it in the life cycle of this one, or with the help of the figure we can show it that what type of cones are called male cone, what type of cones are female cone. In addition to that, it has been observed that the leaves of the gymnosperms are of two types. One that is called scaly leaf. It is mainly to provide protection, to cover it, the parts of the plant. And secondly, that is foliage leaf. It is actually green, photosynthetic and needle-like. It has also been observed that the most of the plants are cone-like. Looks like this, and having this succession is called acropetal succession. It means the older branches are longer rather than that of the newer one. So if you see the structure, then the structure is like this. Like this. You will see the dome shaped structure, the cone shaped structure will see. Here, there are two types of birds. One is called apical bird or apical bird, and another is called lateral bird. It is one of the significant characteristic feature of this particular conifers is the continuous growth of this apical bird. Because of that, the trees are very tall, and a growth is also continued, but very slow. So it has been observed there is a cone-like structures has been observed in it. Stems are woody, covered by the scaly leaves, branched. It has been observed in case of the root that it is of the taproot system also, but it is observed that there is a mycorrhiza mycorrhiza. It means there is symbiotic relation with this particular plant, root, and the certain fungi. So, in this way, we can observe that this is the one of the abundantly available gymnosperm in the cold region. And the pinus is one of the significant, one of the popular example where the leaves are like this. Suppose this one is the branch, and it has been observed that this type of leaves are present at the tip of this particular branch. It is very much common in the Kumaon hills, in the hills where the climatic condition is cold, and in Kumaon hill this particular needle-like foliage leaf is called piroli. We will discuss with the help of the certain figures the life cycle of this particular gymnosperm. Now, come to the cycles. Cycles. Pinus or the conifers are also the perennial plant, and it is also perennial plant. Perennial plant means they produce many times of the seeds in one lifespan. But its stem is erect, not branched. And at the tip of it has been observed that the leaves are present here in form of compound leaf, like this. Suppose this one is the main rachis and having this type of or it is very much pointed part, the apical end is very much pointed. It is thick to reduce the rate of transpiration because they lead their life in warm area. Whenever the leaf set down, they leave some mark on this. This type of plants has been observed, and if this particular is it may be male or female part. It has been observed it has also two types of leaves. One is the scaly leaf, another is the foliage leaf. This is the foliage leaf, and the scaly leaf cover that particular part of the reproductive. We will discuss with the help of the figure what is the life cycle of this particular cycles. You know that the life cycle of the Thallophyta, Bryophyta, Pteridophyta, Gymnosperm and Angiosperm all have sporophytic and gametophytic stages. Previously, we have discussed that the alternation of generation, that is sporophyte to gametophyte, gametophyte to sporophytes. Here we will see that the sporophytes will be started from the diploid zygote. It means a sporophytic part of the plants are always diploid, but their product is haploid. Their product is haploid. So it is obvious, it is very much clear that there is a meiosis. In the case of plant, it is also called reductional division. Now this gametophytic will be started from the spore. Sporophytic will be started from the zygote. and gametophytic will be started from the spore. And now a spore germinate to form the gametophytic plant, gametophytic part of the plant. Just like in the case of Pteridophyta. We have observed that sori produces a spore, and inside sori the sporangium is present having a spore mother cell, and that spore mother cell is diploid. The whole of the plant is haploid and diploid. Their roots are diploid, that is adventitious. Their rhizome internal stem is also diploid. Their compound leaves are diploid. Inside it, at the maturation, their dorsal part have sori, and inside sori, so many sporangium are present. All are diploid. It means that will be started from the zygote, and that is one of the dominant form. They are photosynthetic also. But whenever the spore is produced from the sporangium, then that is haploid, and they produce a again photosynthetic part, which is a heart-like structure, like this heart-like structure, having male and female part. We have discussed in the previous lecture, male and female part, and both will produce. Here you will see that this is haploid. This one is haploid. It means there is no need of the production of there is no need of the meiosis for the production of the male and female gamete. It means both male and female gametes are still haploid. So they produce male and female gamete, and ultimately zygote is formed. In this way we will see that the spore is always gametophytes will be started from the haploid part, and the sporophytes will be from the diploid part. Now, on the basis of the lifespan or this structure, we can study that it is of the haplontic, diplontic and diplohaplontic. Haplontic, diplontic and haplodiplotic. What do you mean by this term? Haplontic, diplontic and haplodiplotic. Here, haplontic means n-conditioned. Here, diplontic means 2 n-conditioned. Here, haplodiplotic means n plus 2 n-conditioned. Both. It's very simple term to understand that if the main part, main photosynthetic part, main functional part is haplontic, means gametophyte. If the gametophyte is dominant over the sporophytes, gametophyte is dominant over the sporophyte. It means the sporophytes are partially or completely depend upon the gametophyte. Then you can say that that life is haplontic life. Just reverse. If this gametophyte is dependent upon the sporophytes, partially or completely, then we can say that it is diplontic. And if both are independent, or one is more dependent, more photosynthetic rather than ones, but both are independent, then we can say that they are haplodiplotic. Now, rest of the part of this particular lecture we will discuss with the help of certain figures and the diagrams. Now it is time to discuss about the morphology and the life cycle of the gymnosperm. In this case, you will observe that the pinus tree, whose leaves are just pine needle like and having scaly leaves are on this particulars. Have cone, and it is called female cone, it is isolated cone, and it is a tree like, cone like. Here you will see that the cone is in cluster, that is male cone, and male and female cone both are present on the same tree, so it is called monoecious plant. Here you will observe that the life cycle of the pinus tree. The pine tree have male sporophylls at this point, female sporophylls at this point, and both will produce microsporophylls and megasporophylls. Microsporophylls are light winged and can fly with the help of the air, and whenever come in contact with the female cone, where meiosis is the main product of the microsporophyll and megasporophylls, then micro and megasporophylls join to form, that is called zoospore, that is called zygote. Now here you will see that the embryo developed and ultimately convert into seed, and the seed will convert into the plant. So this type here, the two-end conditions will be formed, and it is called sporophytic two-end condition, zygote to tree, that is seed to tree to megaspore, microspore, like that, and ultimately before meiosis it is complete, that is called sporophytic phase, and after meiosis that will started with the gametophytic phase. So just we have told you in lecture also that the gametophytic stages will be started from the haploid and sporophytic will be from the diploid. Now in next figure you will see that that is the tree of the cycas. We have this previously told you that we will discuss the pinus and the cycas trees, cycas group of the angiosperm in detail. Here you will observe that the two trees, one is the female tree, another is the male tree, both has separate cone, female and male. Both have two types of the leaf, one is the scaly leaf, brown colored, another is this one, the green colored leaf. It is also compound leaf, here is also compound leaf, in both cases compound leaf. It has been observed that the branching will not take place in any of the male and female, and the old leaf bases are attached in the stem. It means this base is not completely removed after felling of the leaf also. Here you will observe that in female cone, in female plant, the very large ovules are formed. Here is the ovules, and this is the largest ovule in the plant kingdom, where spore, in case of the male, pollen grains come in contact with the ovule through air and fertilization will be takes place. Just you will see here that the zygote developed into the embryo, then to the seed. When seed germinate to form both male and female plant. In the case of the pinus, you will see that the seed germinate to form the single plant, and one plant have both cone. Here the seed germinate to form male and female plant separately. They are diploid in nature. The female cone form megasporophylls and male cone form microsporophylls. Megasporophylls produce megasporangium, microsporophylls produce micro, that is called microsporangium. That is, this micro form pollen grain and this mega form ovule. Now by meiosis, this megaspore mother cell will form actually megaspore, and microspore mother cell actually form the microspore. It is called real ovule, that is called pollen grain. Inside ovule, that is called endosperms are also present. Now this micro gametophytic phase, that is called pollen grains, and this mega both fuse to form the zygote, and this is the end of the gametophytic phase. In this way, we will see that the alternation of generation is also here takes place, but the sporophytic are dominant over the gametophytic phase, because this sporophytic phase is responsible for the formation of the food also. This is all about the life cycle of the cycas. So we have discussed pinus and cycas, life cycle of both, and a simple structure of both. That is the end of the gymnosperm.